Welcome! Today we're going to do a deep dive and absolutely master a multi-part GCSE chemistry question. We'll be using the official AQA mark scheme as our guide, so you can see exactly what examiners are looking for to award every single mark. So here's our game plan. We're going to start by decoding the question itself. Then we'll tackle each part one by one, from conductivity to calculations and all the way to nanoparticles, before we wrap it all up with the most important takeaways for your revision. Let's get into it. Okay, first things first, let's get to the heart of what this question is really all about. We're jumping straight into the world of materials, looking at everything from cool stuff like carbon nanotubes to the tiny but mighty world of nanoparticles. The exam paper sets the scene with this one simple statement. And really, this is the core idea for the whole question. The way a material is built, its structure, directly controls what it can do. Its properties, like how strong it is or if it can conduct electricity. Keep that in mind as we go. All right, let's get stuck into the first part of the question. This is a classic 2 marker, and it's really just testing our basic understanding of structure and bonding. Let's see exactly how we can lock in those marks. So the first thing they give us is this image of a carbon nanotube, and they give us a massive clue. They tell us its structure is a lot like graphene. See that repeating pattern of hexagons made of carbon atoms? Yeah, that's the key to everything. And here it is, the question itself. Now pay close attention here. The command word is explain, and it's worth 2 marks. That's your signal that you need to give 2 separate but connected scientific points to get full credit. So how do we know what a perfect answer looks like? Well, we go straight to the source, the official mark scheme. Think of this as the answer key, our blueprint for what the examiners want to see. Check this out. For the first mark, you have to state that carbon nanotubes contain delocalized electrons. The mark scheme is nice enough to also accept free electrons. Then, to lock in that second mark, you have to connect the dots. You have to explain that because of those electrons, they can move through the structure. It's that movement, that flow of charge, that is electricity. Simple as that. Let's move on to part 2. Now, this is a classic evaluate question. It's all about looking at some data and using it to weigh up the good and the bad of different materials for a specific job. Okay, first things first. Let's get our eyes on the data in Table 1. We're comparing aluminum, carbon nanotubes, and wood. And we're looking at 3 properties: density, strength, and stiffness. We have to use all this info. Just looking at it, what jumps out at you right away? And here's the question. Now, it's for a hefty 4 marks, and that command word evaluate is super important. It means we have to do more than just list off the numbers. We've got to make a judgment call, comparing the materials and explaining which one would be best for a badminton racket, and, crucially, why. So how do you bag all 4 of those marks? You've got to make direct comparisons. For example, you point out that carbon nanotubes are by far the strongest and stiffest, so they're not going to break or bend. But then you have to compare that to aluminum and wood, which are much weaker. A top-tier answer also looks at the downsides. For example, wood is the least dense, so it's the lightest, which is a big plus. Weighing up these pros and cons and coming to a justified conclusion is what gets you the top marks. All right, time for the math part. Calculation questions can sometimes look a bit scary, but remember, the absolute key is to show you're working. If you do that, you can still pick up marks even if you make a little slip up on the final answer. Okay, so our mission is to find the surface area of this tiny cube, a nanoparticle, with sides of 82 nanometers. But don't miss that last instruction. Give your answer in standard form. That's a massive hint about how you're going to get that third and final mark. Let's break it down step by step. First mark? It's for calculating the area of just one face of the cube. Since it's a square, that's just side times side. So 82 times 82 is 6,724. Boom, first mark in the bag. Next up, for mark number 2, we need the total surface area. A cube has 6 identical faces, right? So we just multiply our first answer by 6. 6,724 times 6 gives us 40,344 square nanometers. And just like that, that's our second mark. And for the grand finale, that third mark, we have to follow that instruction about standard form. So 40,344 becomes 4.0344 times 10 to the power of 4. The mark scheme is happy with it rounded to 2 significant figures, so 4.0 times 10 to the 4 is your perfect answer. And of course, don't forget your units. Okay, let's bring this home with the final part of the question. This is where we connect all this nanoparticle knowledge to something you might actually find in your bathroom cabinet. It's all about applying what we know.
Here we have a 1-mark suggest question. It's asking us to think like a scientist and maybe a bit like a manufacturer. Why is it cheaper to use these tiny nanoparticles in sun cream instead of just bigger, fine particles?
And look at that. The mark scheme actually gives you 2 different ways to get this right. You only need one. You could go with the straightforward, practical answer. You just need to use less of it to get the same sun protection, and less material means lower cost. Or you could give the core scientific reason. Nanoparticles have a much greater surface area to volume ratio, which makes them more efficient. Either one of those gets you the mark. So, we've taken this question apart piece by piece with the mark scheme by our side. What have we actually learned? What are the big takeaways for your exam technique? Let's quickly recap. It all comes down to really understanding those command words, doesn't it? Explain means you need to provide linked scientific reasons. Evaluate is your cue to use data to weigh up pros and cons. Calculate screams show you're working and watch for details like standard form. And suggest is all about taking what you know and applying it to a brand new situation. Nailing these skills is the key. And that brings us to the end. So, as we wrap this up, take a second and think about it. Which of these skills do you need to practice the most? Is it the detailed comparisons in an evaluate question, or maybe the step-by-step precision needed for a calculate question? Pinpointing where you need to focus, that is the secret to revision that actually works. Thanks for joining me, and good luck with your studies.